Welcome to solverfy.
In this question, we have this setup, whereby we have a gear that is rolling on a fixed gear rack. Okay, and then we have a cord that is wrapped around the inner spool of the gear. And then at this instant, the cord is moving to the right with velocity v, and the velocity is constant. We need to determine the velocities and accelerations of points A and B at this instance. Okay, so since the gear rack is fixed, so we note that this point is going to be our instantaneous center of zero velocity. Okay, so we can determine omega. Okay, omega will have magnitude v over r. Okay, and then from here we can determine VA. Okay, VA will just be omega cross R A relative to IC. Okay, so this is equal to V over R. So this is going to be the direction of omega. So it's negative V over R K cross. So the position of A relative to the instantaneous center of zero velocity is going to be minus 2Ri plus 2Rj. Okay, so this is going to be 2V, and then minus k cross minus I gives plus j, and then minus k cross j gives plus I. Okay, so yeah, so basically this direction is going to be our VA. Okay, so the magnitude of VA is going to be 2 root 2V. Okay, and then the direction of VA is 45 degrees above the horizontal to the right. Okay, and then we have so just box up the answers for VA. And then we have VB. VB will just be omega cross RB relative to IC. Okay, so this is equal to minus V over RK cross for R in the J direction. So this gives for V in the I direction. Okay, so VB is equal to 4V, and then the direction is to the right. Okay, so this is the answer for VB. Okay, next we move on to the acceleration. So for acceleration, we note that because V is constant, okay, so at the center, the acceleration will be 0. So we expect that the angular acceleration of the gear will be 0. So using the relative acceleration equation, relative from G will be AA equals to AG plus alpha cross position vector of A relative to G minus omega square R of A relative to G. Okay. Okay, the first two terms are 0, and then omega is V over R, and then you square it, and then position vector of A relative to G is minus 2R I. So this gives 2V squared over R I. Okay, and then for AB, So this is AG plus alpha cross the position vector of B relative to G minus omega square position vector of B relative to G. 0 plus 0 minus B over R square to Rj, and then this is equal to minus 2b squared over Rj. Okay, so just boxing out the answers. And then that's all.